All right. Back to density curves and normal distributions. And I'm not relecturing this whole thing. Whoop, too far. I'm going to go on to the problems we're working on. As a matter of fact, I think it would not be a bad idea to look at number 3 if there was anything in number 3 that caused you concern, either when I did it the first time or we do it now. So, did anybody have any issues with number 3? Did we finish all of them?
No. Wait, sir.
Yes.
I had an issue with the location of the median.
Oh yeah, this one, the extra credit one? Number 2?
No, sir, for Oh, yeah.
Yeah, but number 2 actually asked you what the median was. Why don't we do that one right now? But I'm going to do the geometry, not calculus. A lot of kids turned in the answer and they used calculus, which isn't illegal. They were just cheating. The median depends how you look at it.
How many people did the extra credit?
On this problem here, I haven't done anything with it yet. Oh, how many? Probably about 6. And only one person is getting credit for not the full exact answer because she worked so hard. Let me share with you what the answer is. Median. Shh. Median means cut the data in half. So this is 50% and this is also 50%. So the easiest thing to have done is to just use that triangle and find out what this x value has to be to get 50% to the left of that line. So the final answer, the exact answer is square root of 2, which is why those of you who tried plugging in numbers, 1.3, 1.4, 1.45, 1.5, you were never getting it. Even somebody who did 1.41, they thought they were so smart because the calculator almost showed it was 50% area, 1/2. But I explained, unless it says 0.5 with that's it, you weren't exactly right. So, with the geometry,
So I can move, sir, or no? I can.
Oh, wait. So
what's that?
Oh. So you find the area
Of just that triangle. Well, we know the area. We know the area formula is base times height divided by 2. And we already know that area is 1/2, right?
Yes, sir.
So if I have this right now without doing any extra work, what cancels out with just algebra?
2.
All right. Lot of noise in the background there.
Boys. Sorry, sir.
Your next spot's going to be a desk facing that way. So 1 is equal to base times height. So if I start with that, that's an easier equation. And if I'm looking at the problem that I just highlighted off, what is the base of this triangle?
Right there? That's
Do I know how long it is?
no, sir.
No.
I don't. So what do I call it? Unknown. X. So 1 equals to X.
Can you just relate base and height to each other?
I'm going to do the height right now. What was the equation of this line that related the base with the height? What was that equation?
Half.
Well, give me the whole equation. The height equals to y equals to 1/2 x. Do you remember?
Yes.
That's the height. Was the y value. So if this is x,
Why did you?
What-
We have to use the line to find
1/2 x.
We could have just equaled the entire area, which is 1, and put the 2, and put the 2 as the base of it, and solve for the height.
No, it wasn't. I wasn't.
What do you mean?
I'm not.
'Cause we
I
know
guess you could have tried that.
So the entire area is 1.
But I wanted where the x value was for 1/2, not for 1.
In order to find the height of the
Hold on to your thought, because I'm almost done, and you're confusing me. I'm not saying you're wrong. So I'm left with 1 equals to 1/2 of x squared. To solve that, I get rid of the 1/2 times 2. So 2 equals 2x squared. To get rid of the square, I do what?
Square root.
Square root both sides, and that gives you x equals to the square root of 2.
So simple.
It was a lot simpler than plugging in a number into the formula that people did.
Yeah.
And so one girl, she had 1.41, and I think she even had one more decimal place that was actually correct for the square root of 2.
It's 414.
414? She had that, but then she had other decimal stuff that didn't match to the square root of 2. It was so close. When she plugged it in, though, she said, I have to be right, because my answer is 0.500005. That's, I think her calculator ended something there. And I said, you're so close, but because you have some extra stuff there, it's not exactly 0.5. But I gave her the credit, I'm giving her the credit anyway, because she did like 2 pages of number crunching. But
Wait, why she need 2 pages?
because she kept trying different decimal numbers.
Try harder.
She got to 1.414.
She didn't.
And huh?
She didn't realize I was just.
No, I guess not. But let's be honest. You put 100 people in a room. I don't know how many would recognize the square root of 2. I said 100 people. I don't know how many people would. I mean, maybe. I mean, if I say that to you, what's the square root of 3? If you can do the square root of 2, 1 point what? 7 1. See, 1.71 something. We're not really sure what it is. But if we see it, we might be thinking it. But somebody would have to give you a clue that the answer was not rational. Then maybe you'd be thinking of square roots of 2, square roots of 3, square roots of 5. Maybe. So in all fairness, she deserves it. Okay? All right. So that was a good one, whoever said the median of that problem. But they were actually asking for the median of number 3. The good news is number 3 did not ask you to calculate it. It said, draw it, right? Right here. C. Draw the approximate location of the median. Well, median still means 50%. So what if you said, well, I think it's exactly here. I think it's here. I know it's not, because I think we already did some calculations. So let's do the calculation for the area of the rectangle. That area is base times height. What's the base? No, it's not 5. 0.4. What's the height?
1.
Went up to the 1. So that's 0.4. So that you ought to be saying to yourself, that can't be the median because it's not enough.
Yes, sir.
So if all I have to do is draw it, I don't have to find it,
A little bit more.
I would just draw it a little more. Can you step outside? And you let me know when you're done. Go out there, giggle, have fun, okay? Wear yourself out. So when you come in, maybe you just fall asleep. Yes, sir? You had the pass? So I'm going to draw it just a little bit to the right of that red line and call it the median.
Yes, sir.
I don't know what that value is. I could find it. I do have the power. All I have to do is find a trapezoid that has an area of 0.1. And since I think we did already calculate the equation of that line,
Can we go ahead and do that then?
no, I don't want to.
Oh, okay.
But, I mean, I'm just like you. I don't want to do extra work if I don't have to. But I know I could if I want to spend another 10 minutes on it. All right. So let me go on to us to know is if I drew my median here, where would the mean approximately be?
To the left.
To the left?
Yes, it's skewed to the left.
So is it possible that red line could be the mean?
Could be.
See, the key is the skewness pulls
It's towards
the mean.
the tail. Yeah.
So it did pull it. So that could be the mean. Or it could be farther, I don't know. But all you had to say was to the left of the median.
Wait, sir, how would we calculate the mean here? Like, how would we?
I just said, you already know this was 0.4.
Yeah, but like, yeah.
Let me go back to my picture over here. It's Next page, I put a couple copies of this number 3 in case there's something here you wanted to do. Was there anything else in number 3 that anybody would have needed help on?
Oh, sir, F, is it skewed left or right?
What was the class's response? What would you think? It would be left because that's definitely a tail compared to this. It definitely, if you were to draw like a curve over it, you would draw like that. I mean, it went down, so it's got skinnier over here.
Steep, but like,
Yeah, I know, but it is skinnier than that. I mean, granted, it's a fat tail, but it's still a tail.
it's funny.
Skewness always has less area than it did the other way. This has more area over here. This has smaller area.
So it is skewed.
Yeah, it is skewed.
Despite half of it's being.
So you already answered F. Was there? We already answered G. No, we answered E. Oh, let's answer. Let's go back to what is the relationship between the median and the mean?
Mean value. Sir, you said median. No, I said, I'm talking about mean now.
Oh, well, we can't.
We can't, right?
You don't have the data.
Yeah, that's fine.
You don't have the data. You can't. I thought you said the median. No, you can't find the mean because it's a skewed. If it was symmetrical, it would be exactly where the median was, and that's easier to find. But if it's skewed, all I know is that it moved the mean. I just don't know where it moved it at. Okay. Last chance for number 3. Okay. All right. Then let's look at number 4. How far did I get on number 4 with you guys?
Not at all. Not at all.
Not at all?
Not at all, sir.
Yes.
We're about to start now.
All right, so let's set this one up here. I'm going to draw the picture one time and then just copy it. A density curve consists of two lines. The first line goes through point 0.8 and it goes through point 6, comma 0. That sounds like a pretty easy line to draw. So 0.8, here's x is 0, here's 0.8 up here. So I'm going to put a point. The next point goes through 0.60. So if a 1 was over here, then 0.6 is probably right here. That would be 0.60. So I'll label those 0.8 and 0.6, comma 0. And that line looks something like that. The second line starts at 6, comma 0 and goes up to 1, comma A. Now, A is some value on the y-axis. I just don't know where it is. A could be here. The distance could be up here, here, here. I don't really know. So my answer that I get in a little while may not match my picture since right now I don't really know what A is. So let me just pretend to draw it up here. Yes, and I'll call this. What's that? Yes. So I'm going to put that point there, put it in red. That's going to be considered 1, comma, some A that I don't know what it is. And he says that this picture is a density curve, so reminding you the rules of density curve. Oh, why can A not be down here?
So it's not negative.
Right, it has to be, that area would be negative area. Can't have any area below, so A has to be up, somewhere up here. And the other rule was the area under the density curve has to add up to what? 1. So I have a right triangle here and a right triangle here.
It's 100 there, right, sir?
100%.
No, but like it'll be
Wait, the area always has to add up to a 1?
That's right.
like it'll
Is
be
that like a rule?
Yes, that is the rule. So I'm going to save this picture because I think I'll use it more than once.
Sir, but when you calculate the area of the
Go ahead.
wait, never mind, my bad. I'm stupid now, sir.
I'll move it up there out of my way. So
Freaking retarded.
what is A asking us to do?
It's to find A.
Find the value of A. What, oh, good.
We gotta find the area of the other.
What is this value here? So in order to do that, let's use what we were just talking about. Let's say, didn't we say the area total is 1?
Yep.
Sir.
So area total has to be area of rectangle 1, right here, plus area of rectangle 2, right here. Got it? Does that make sense so far?
Yes.
Okay, so the area of the first one is 7.7.
Let him do it, Joel.
So area has to be 1. Base times height, divide by 2, plus base times height, divide by 2. Obviously, those are different bases and different heights. I could put scripts, base 1, H1, base 2, H2, but you get the point, right?
Yes.
So the first triangle, what's the base of the first triangle?
0.6.
What's the height of the first triangle? So 1 equals to 0.6 times 0.8, all divided by 2, plus, what's the base of the second triangle?
0.4.
Because this is a 1, right? 0.4. What's the height?
I don't know that.
So I give it a variable,
A.
A. It's already called A. X was fine too. Divided by 2.
That's right.
So I have an awful lot already done. I only have one variable in that whole equation. And you guys are all advanced placement students, so I could stop right now and just say, you guys could just finish it for me, right? Save me the hassle, but let's go ahead and look at it. 1 equals to,
1.5.
well, 0.6 times 0.8 is 0.48 divided by 2.
124.
So that must be the equation, that must be the area of the first triangle. Plus, how could I simplify 0.4 over 2 times A? 0.4 divided by 2 times A. 2A? 0.2A. Now, you should be able to pick up your calculator and do the next 2 steps without us writing anything down. What would the steps be?
Subtract 0.24 and then divide by 0.2.
So subtract 0.24 from both sides. So pick up your calculator and type in 1 minus 0.24. What does that give us?
0.76.
And then I got to get rid of this nasty 0.2 next to the A.
So it's 3.8.
3.8. Did anybody else agree with 3.8? So, yes. So what I'm going to do is I'm going to label that picture up here as A is 3.8. Hey, I drew it higher than 0.8. At least it's higher. Question? Yes.
When we're calculating the slopes of those lines, can we use, what is it? 0.6 as our origin?
No. The origin is not at the 0.6.
Can we use the 0.6 as our relative?
Let's see. Are you trying to do another problem?
No, the same.
Are you the same problem? Well, why do you need the origin right now?
We'll like to calculate the slopes.
Oh, you can use point. You can use those points. This was 0.6, right? Yeah, you can use that as a point, and you can use. Now you got that point, and you also have that point. So you got enough points to find slopes.
Yeah, but I'm saying like, because we're gonna have to calculate.
Yeah, I'm gonna do that right now.
Yeah, but could we just use 0.6 as our origin instead of having to calculate?
No, because your y-intercept won't be correct.
I'm not done. I can tell you what it
We could
is.
just find area one and
Yeah.
so we can-
Oh, it might give you an area, yeah, but it won't give you the equation of the line correctly to find the actual height of the other pieces. All right.
Whenever you want. Thank you. No problem.
All right, guys. Let me copy this picture. And
Like so many chapters, I'm like on chapter 6.
all right, let's work on the next one here. We did A. What is B asking us?
What percent of the data lies below 0.6?
Oh, I think we already have that answer.
24%, sir.
We did that accidentally, right? And what's the percentage that lies below 0.9? Have we done that one?
Oh, heck no, sir. What do you do?
All right, so where's 0.9 at?
After 0.6.
Somewhere after 0.6. I couldn't have said it any better than that. So let me just pretend it's to make it visible. Let me draw it right here, 0.9.
How would you calculate the height, sir?
And I want below this. So I want all of this area plus all of this area. And Joel's already thinking about, well, what am I going to need? Well, I already have the area of this triangle. That's 0.24, right?
Yeah.
I just need, I'm going to call this triangle number 3 because it's this small one right here. And Joel's already thinking, what's the height? Well, the height is going to be related to the y equals equation of which line? Of this line. And I know Dio was also thinking about it too because he was talking about the slope of that line already. This is not called an origin. It's just a point on the line. So what I would do if I were you is find that slope. So slope of that line that is dependent on the height of this triangle. So the ordered pairs I have was,
0.6.
I have, say it again?
0.6, comma 0.
Oh, those are the points? 0.6. No,
No, 0.6, comma 0.
I don't use 0 points. It
Okay,
bugs me.
0.6,
0.6, and the other point was
1, comma
3.8. So using those 2 points, I can find the equation of this line right here. So I'm going to go this way. 3.8 minus 0 is 3.8 over 1 minus 0.6 is 0.4. What, no, was it 1? Yeah, it was a 1. So what's that slope? Feel free if you just want to.
9.5.
How much?
9.5.
9.5. I'll write it. Yes.
Wait, so we just multiply it?
1 minus 0.6. Y2 minus Y1. X2 minus X1. So now that you have that, I need to know what the y-intercept is of this line right here. And be prepared, it should be a negative number. Because if I extend the line, it's down here. So don't be afraid if the b is negative. It should be negative. So here's my method. Y equals mx plus b because we have the slope. You just found it out right here.
Yes, sir.
And I can take any point that I want. You just got to decide which of these 2 points do I want to use. The first one. So the y value is a 0. 0 equals 2. 9.5. The x value is a 0.6. 0.6 plus
B.
b.
Solving for B, right?
Solving for b. So in reality,
0.6 or 0.9?
that was 0.6. That's a 0.6 right here.
Oh, okay.
Because you're going to find
I used that point right here, if you recall. I said we got to pick a point. We chose that one. So somebody tell me what 9.5 times 0.6 is.
5.7.
And so you're going to move it to the other side. That makes it a negative 5.7.
Yay.
And I did tell you, don't be afraid if it's negative. It should be negative. So I have my equation. Y equals to 9.5x minus 5.7.
Okay.
What? So you repeat that? 9.5x minus
Yeah, 9.5x plus a negative 5.7 or minus 5.7. That's the y equals equation, which stands for the height of this triangle that I was shading in green, if you recall. Remember?
Yes.
So in a second, someone's going to tell me what that height is.
So we just plug in 0.9 to the equation?
In a minute, yeah, you will. Absolutely. I didn't tell anybody that yet, but that is what you're going to have to do.
We're gonna have to do it.
Yeah, we'll have to, yes. All right, so to answer this question, area total equals triangle, the area of triangle 1 plus the area of triangle, I called that 3, remember? The small green one?
When doing tests, do you want us to do this? Area of triangle 1.
I think it's proper communication. A lot of you like to do scratch work all over the place and say, bingo, here's my answer. That's fine, it does work, but it makes it a bear to try to go back and figure out what you did. At least I have a thought process that my total area is going to be these two triangles. And the good news is, I already know this first one was 0.24
Yep.
plus base times height divided by 2. And I just told you a second ago
2.85.
that somebody's going to have to do some work for me because now I got to plug in some numbers. Equals 2.24. What's the base of the green triangle?
0.3.
It isn't 0.4. It doesn't go.
I said 0.3.
Yeah, it's 0.3. It only goes to 0.9, remember? 0.3. Okay. I was asking somebody to calculate what that height was going to be.
2.85.
By plugging in a 0.9, that would have been, the height was 9.5 times 0.9 minus 5.7.
Which is 2.85.
2.85?
Yep.
Thank you guys, appreciate it. So that's 0.3 plus 0.3 times 2.85, all divided by 2.
Oh, yes, okay.
So,
That would be 0.25.
so all you gotta do is plug it all in the calculator. 0.24 plus all of this.
Yes, sir.
What is it?
The whole answer?
Yes,
0.6675.
0.6675. Tell me about the next decimal. Or is that the exact answer?
That's the exact answer.
Okay, in AP Stats, if you're going to give decimal answers, now if he turns it into a fraction, he could just type it as a fraction and leave it. You have to go to at least 4 places.
Oh, wow.
And if you go for the 5, you better be accurate on that 5th one or you'll get it marked all wrong. But
So you don't round?
I never round. I just truncate. I just cut everything off.
Okay.
I don't care what's after the 5. Even if it's a 9, I just ignore it because I don't want to accidentally make a mistake in rounding. I rounded when I wasn't supposed to. So that's letter B. That was a lot of work.
I think we can do the rest by ourselves.
Oh,
Probably. But I don't want to if
Give you height, right?
I don't know if that's a...
do we want another one?
Yeah.
Sure.
Then pick D, E, or F. Pick it. What percent of the data dies above 0.1? So
Are you doing, wait, sir, what are we doing?
we're going to do E because inquiring minds want to know.
Mr. Cartwright?
Yes, sir?
But B through E are like basically all the same.
No, that one
No,
is below,
that
it's
one's
above.
above.
I know, but like they're basically all the same.
Yes.
Why don't we do 2?
Let's
That
do
one
F.
and then
I don't know. We're going to have time now because you guys took too long on your quiz.
Mr. Cartwright, let's do F.
All right. Well, okay. I agree with Dio that E is exactly the same thing we just did with 0.9. We're just going the other way.
Yeah.
All you'd have to find out is, I'm not going to do it, but I'll draw it. 0.1 is about here. And in this case, all you got to do is find out what the height is of that triangle is, which, by the way, you already have the y-intercept. All you need is a slope. You think you could do it?
Yeah.
It's algebra. Let's do it real quick. What's the slope of that? We're going to go from point 1. So I'm going to color everything in yellow. This triangle and all of this triangle, which, by the way, we already knew how much this triangle was. What was it? 0.74. So all I need is this triangle right here. I'll call it triangle number 4 now. Triangle number 4. So what's the slope of this line? Oh, so it's okay. I followed the leader, so I copied it down. So the slope, I'm not going to do it so slow. We know that this ordered pair was 0.6 comma 0. This ordered pair was 0.8. So slope is going to be 0.8 minus 0.8 over 0 minus 0.6, which is negative 0.6. Are you surprised that it's a negative slope? No, because it's a negative slope. It goes that way. So the answer is a negative 4/3. How do I know? I moved the decimal once, reduced 8/6.
Wait, sir, what points did you use for the slope?
0.8, the y-intercept,
Uh-huh.
and 0.60.
The answer is negative 4/3.
That's the slope. But the equation of the line, though, is going to be y equals to negative 4/3 x plus b, but I know b, 0.8. This is e. This is e. So now the height of this triangle, the height would be y evaluated at 0.1. So all you got to do is plug 0.1 into this, and you will have it. So I'll let somebody key that in and tell me what it is. I'm waiting for 4/3 times 0.1 plus 0.8 is exactly? Oh, that's awesome. 2/3.
It wouldn't be negative anymore?
No, the y, you're plugging in the y 0.1. The height has to be positive. The negative was the slope, negative 4/3. This is equal to a negative 4/3. Are you sure it's 2/3? I don't remember that yesterday. Did you use a negative in front of the slope?
Oh, it's negative slope?
Negative slope.
Yeah.
Double check. Negative 4/3 times 0.1 plus 0.8. You agree with 2/3?
Yeah.
Okay, 2/3 it is. So area total will be base times height of this yellow triangle from 0.1 to 0.6. What's that base?
5.
Times its height was, you're saying, 2/3. Plus, I already know this was 0.76. Key that in, and Sophia's got her answer for E. 1 what? No, it can't be 1.0. The whole area can't be bigger than 1.
So you need to divide the.
Oh, I forgot to divide by 2? Oh, I'm sorry. So he's right. I just didn't tell you to divide that by 2. Thank you very, very much. You know what? I'm embarrassed. I did that mistake yesterday too.
It's okay.
And somebody caught it sitting in your chair, Aaron. She caught it. And I gave her 5 points. Wait, who caught it this time? Same chair. 5 points on the next assignment. Just got to remind me.
Wow.
I usually give the points when I'm kind of embarrassed that I made a dumb mistake. Now I'm embarrassed I made it twice, 2 days in a row, the same exact thing. Wow, that's crazy. We never learn. Final answer? Point. 0.9266.
2/3. 2/3.
And it could go 6-7 if you want to round, right?
You could.
But I choose not to.
You truncated it.
Nice job. You know what? I know somebody was saying we don't want to do this problem because it's like the other one. But actually, I think it's a good practice.
So how do you find the median?
All right. Do we really have time? Yeah, I think we have time. I do need to talk about the next set of notes with the normal probabilities, though. Median, is that what it's asking? Letter what? F. What, does he want to know where it is?
Yeah, what it is. No,
Or what it is? Median, okay. So median stands for how much percent? 50% from the left. So we already know this is 0.24, right? I need to steal some from this triangle.
Yeah.
So I'm going to call it there. I'm just going to call it X, and it's my median.
0.26.
I don't know.
It is 0.26.
Well, no. Oh, I know what you're saying. You're saying all I need is 0.26 area. Great idea. I'm glad I thought of it.
Exit points there?
I'm glad I thought of it.
Oh, okay. Can I have extra points? Can you have extra points?
Yes, I can.
Oh.
So the area has to be 0.26, thanks to Joel. So yes, Joel, remind me. Has to be base times height divided by 2. Don't forget this time. And so my base is what? Do I know where this number is?
No.
Then just call it what? So 0.26 has to be equal to x. And what was the equation of this line? Remember, it's up there at the top. We did it once. Y was equal to 9.5x minus 5.7. So guess what the height is? You're going to hate this.
That itself.
It is, yeah. 9.5x minus 5.7, all divided by 2. How do I get rid of the divide by 2?
You can, after you foil the x, you can do it.
Well, it's not foiling, it's just, that's just a distributive, right? Can I multiply both sides by 2 right now and get rid of this pesky fraction? What is 0.26 times 2?
What's the x in the equation?
152.
What is what, sir?
Why'd you put an x?
X is
What is
the,
the
it's
slope?
where the median is.
Why did I put 9.5x minus
No,
5?
The first x.
X is the median.
Base, the unknown value.
That's the median. That's where the median is.
This distance here is some x value, which we know it's going to be bigger than points. Oh, I hope it's going to come out bigger than 0.6. Oh, wait, it's going to give us the distance from here, so that's okay. Now I have distribute that x that Joel wanted to do. 9.5x squared minus 5.7x. This turns out to be a lot uglier than I was thinking. Make it into a quadratic.
Equal to 0.
Equal to 0. So 0 equal.
Is it correct?
Yes.
Why you put 0.52?
Because 0.26 times 2.
Oh.
0 equals to 9.5x squared minus 5.7x minus 0.52. And so I'm at the mercy of my calculator.
How do you do the graph it?
Graph it. It should be a parabola, and it's going to have to cross the x-axis somewhere. Somewhere. It's going to have to come up into the x-axis somewhere. Go to your calculator. Look for the 0. Look for the 0. I wish that first row over there was all working on this. It would really be good. I got a couple people in that row. Anybody find it?
Are we trying to find the x?
Yeah. That is the x.
It doesn't want to graph.
Doesn't want to grab. Zoom. Do a zoom fit first.
Same tool.
There's the positive one, right?
Yeah.
0.68. I got
Think way too long.
Yeah.
0.68. Is there a lot of decimals?
0.6804.
Okay, I'm going to force myself to use more than the 4 decimals to make sure I don't lose anything. So x is approximately what? And I'm trusting you guys. This is going to be online. And if the answer is wrong and somebody much smarter than us does the problem and says, hey, well, you guys are all wrong. Point what?
6804.
Yeah, that's what I got.
More decimals.
6804443.
443, okay. So that has to be added to the 0.6. Actually, it doesn't, really. Yeah, I do. I have to add it to that 0.6. So the median should be 0.6 plus 0.680443.
1.2.
So something happened. and it
Wait.
didn't work.
Can't be. It can't be 0.6. We are all messed up somewhere. Maybe I messed up somewhere. Where are you at? What? Where are you at?
We started with the point 26.
Because Joel said I just needed the area of this triangle.
Mr. Carr, which zero are we using?
Is there two positives?
There's one negative.
So it should be a positive.
Wait, Mr. Carr, I'm confused. So wait, we're calculating.
Where they expect, yeah, the median, to give me 50%. And Joel is correct that 0.24 plus 0.26 is 50%. So the X here should be the place where it's at. The problem is, I don't think it's 0.6. It can't be, can't be 0.6. Wait.
So the equation I graphed was 9.5 x squared minus 5.7x minus 0.52, right?
Say it again?
The equation we graphed was 9.5 x squared minus 5.7x minus 0.52, right?
Right.
And then I graphed it, and then. we
See,
solved for
see,
that.
to me, something happened that, to me, could be the median.
Yeah.
That would make sense.
Greater than 6.
But, oh, and maybe it is because we did use this line. Well, let's test it out, just for kicks. Take that answer, times it by the height that we had, which was what? Well, we didn't plug it in. You'd have to test it. I'm going to see if that is actually giving us the total area of 0.5. So what I want to do is, I want to take the 0.26 plus the base, if we think that could be the answer, 0.68044. What was that last number? 3?
3.
Times. Take that answer x and plug it into that equation we had, this one right here. Y equals to 9.5x minus 5.7. Take that answer, plug it in, give me that, the height.
0.680443?
Are you plugging it? Yeah. Plug it into there.
We graphed the equation, and then we just got a 0.
0.52.
It's 0.52.
Yeah.
Well, there's more decimals, right? He got 0.56. What?
You get point. Oh, well, like for the total, like after you get
Oh, you did the final area.
Yeah.
Oh, so it's too much.
Yes,
A little too much. So we're wrong either way. We'll save this. We'll do this again at another date.
Extra credit?
Interesting.
Yeah. Yeah. But this time I'm going to put my foot down. It's the first person who either gives me the paper or sends it on remind. Yeah, if you, we could do it again, but I won't have time to finish what I need to finish up, so you can do your homework. I gave you a remember? That was so close though. In your videos that I forced you to watch from other people, some of it was overkill because one even went into calculus,
Yeah.
but you didn't have to do that. But if we made a histogram of all weights of everybody in the Rio Grande Valley, everybody, that's an awful lot of data points, right? It's an awful lot of people. It'd make a histogram that looked like that. if we did the SAT scores of everybody in Texas, it would make a histogram that would make a normal curve. Almost anything that you can quantify, if you grab the whole population and make a histogram, it'll look like that. And he gave you a whole bunch of things: weight, height, what was this one? Human body, about fingerprint lengths and hair lengths and how many eyebrows they have, eyebrow hairs they have, everything. Prices of things, money that people make, time it takes to go to work. Everybody in the valley, how long does it take to go to work? You're always going to have a normal curve, always. Okay? So the beauty of this lesson is, this is my naked normal curve. And if we're talking about a population, this middle is the same as the median. It's also called the mean, which is called mu. The same Greek letter used for friction, the coefficient of friction in physics, is mu. It stands for the average of the population. And since this is a normal curve, symmetrical, this is also the median. Now, if you go and talk about the standard deviation is called sigma for the population. For the, when we had a set of data, we called it X bar and S of X. Remember?
Sir,
Yes.
It's called what?
Sigma. We had X bar and S of X. That's for a sample. This is for the population. These are called statistics. These two are called parameters. Anyway, if you go 1 sigma to the right and 1 sigma to the left, minus 1 sigma,
One standard distribution.
yes, that area here will be considered 68% of all of the population.
Isn't there like decimals though, 68?
Now, the empirical rule is just rounded. The calculator answer would not be exactly 68.
So we go 1 sigma to the right and 1 sigma to the left?
Exactly. It's 68% of the people. If we go 2 standard deviations, this is 2 sigma, and then a minus 2 sigma, this area constitutes as 95% of all the data.
Interesting.
It is. If you happen to have nothing else to do and you go 1 more sigma to 3 sigmas to negative 3 sigma, this constitutes as 99.7% of the population. Just about everybody is within 3 standard deviations.
And then isn't the infinity and negative infinity is like
Well, the point is, this thing still keeps going, and this thing still keeps going that way as well. Shaquille O'Neal's shoe size is over here. He's probably like 5 sigmas. Because he's unusual.
Unusually high amount of something.
Okay? So, what they wanted you to do in some of the problems is not use your calculator, not use the normal CDF. Use these empirical numbers. Yes?
Sorry, for
Thought process. I want to.
the second distribution, what was the percentage again?
95. All right, so let's look at this first example. There is really here a naked normal curve. And so the distribution of all heights of all American men is approximately normal, with a mean of 69 inches and a standard deviation of 2.5. So these two numbers I have to identify. And I go to my picture and I label this as 69. And then I add a standard deviation, which means what's 69 plus 2.5?
4 sigmas.
71.5. Add 2.5 again, what do we get?
74.
74. And to the third one? That's to the right. Now I've got to go to the left. 69 minus 2.5. Joel, you already have it done? Joel, did you find it? Joel. Oh, why'd you send an attachment?
I did. I sent it, yeah.
But is it correct?
Because when you
Did you find our mistake?
when you put the calculator, no, there's no mistake. It's just that it wasn't when you put the decimal, it wasn't exact.
Oh, is that why it was giving us more?
Yeah. Because when you were to ground set and you would find zero.
Yeah.
There was two zeros. There's a negative zero and then a positive zero, right?
Yeah.
Because it went underneath the curve, underneath the x-axis, but the top one, it was giving it 1 raised to the power of negative 13.
Oh.
Zero, but not zero.
Okay.
I put it into I did it again. I got 3/10 equal.
So we were off on the actual value of the, okay.
I put 3/10.
So you're okay with our process then?
Yeah, square root of.
He really wants extra credit.
Hey, if I don't have to do the problem again, he gets it. I don't want to do it again. All right, 69 minus 2.5. 66.
Wait, I thought it was 60.
66.5 minus 2.5 is? 64. And 64 minus 2.5, the third one?
61.5.
All right, so what we're going to try to do is answer these questions without having to use a calculator. What percent of the men are shorter than 64? So I have to find 64. Well, 64 is already done for us here. You see that?
Yeah.
Now the question is, do you realize that this is 2 standard deviations left? And I want all the people shorter than this. So this is actually the area of this tail. Well, watch how easy it is to do the area of that tail. We know that from 2 standard deviations to 2 standard deviations was how many percent?
95.
We know this is 95. If that's 95, then the 2 tails have to add up to how much?
100.
The 2 tails. 5. So this one tail that I want has to be half of the 5. So this answer is 2.5%. Or if you want to write 0.025, you can. So how did I do that? I did it by finding the area of the tail based on the 2 standard deviations left and right. Questions? Letter B. What percent of the men are taller than 71.5? Okay, so I'm going to erase my work. You have to draw another picture somewhere because I'm sure you wrote over it. So I'm going to get rid of this part right here, just so you can see what I'm doing. I want taller than what?
71.
Where's 71.5 at? Right here. It's 1 standard deviation. So I want taller than this. So what? The tail is where? Here. So all I need to know is what the area of that tail is. But be careful. There's a trick.
Mr. Cartwright?
Yes.
I think that A is supposed to be 2.35.
No, we're not doing the exact answer. We're doing the empirical rule, approximately. Because we're not using a calculator. Okay? So, 1 standard deviation to 1 standard deviation is what percent? 68. So the total of the 2 tails must be how much? 32. So what's this one tail? 16%. But be careful. The answer is not 16. It's not 16% because
It's 1 minus 16.
it's 1 minus 16%. Or 1 minus point, let's do it this way, 1 minus 0.16. Because I want the area to the left. This says I want smaller than this height.
Wait,
No, it's just
Sarah,
taller.
taller.
Oh, taller, I'm sorry then.
Did the answer
That's what I
be
mean.
16%?
That's what I mean. I want to get rid of this. 100% minus 16% is how much?
Wait, sir, is it the answer?
84. So it's either 0.84 or 84%.
Wait, sir, I thought it was.
Wait, how can 84% of people?
That's how many is
Taller. It's asking for taller.
What?
hold on. It is this tail. I stand corrected.
So it's just 16%.
Yeah, Dio, you got it.
Extra credit.
Yeah.
Yes, sir.
Did I give you any yet today?
No, sir.
Oh, bummer. It's okay. You deserve it. You're paying attention. It is 16. It is 16. What was the 84?
The other part.
It said, I thought it said shorter.
If it says shorter than 71.5, then we subtract.
If it was shorter, it would be 84%. Right?
Yeah.
All right, what's the third one say?
Are you mad?
Taller than what?
Taller than 66.5.
Taller than 66.5. So 66.5, okay, is the one standard deviation. I think we already calculated this tail.
84.
What's this tail? 16. I want taller, so I want all of this. That is 84%. Nice job. D. Middle 95%. Well, how many standard deviations is the 95?
That's 2.
Okay, so if that's 2,
From 64 to 74.
how'd you do that so fast?
By looking at the x point.
Okay, 2 standard deviations here and here. Right?
Yeah.
That gives us 95. So those would be the answers. Those are the 2 heights.
Extra credit.
No, that was no mistake. D. E. At height 74 corresponds to what percentile?
95th.
This came up in your worksheet. That means 74% are shorter. So I want to find the value where it's 74% to the left.
Wait, 74%, 74 inches.
Wait, Mr.
Oh, yeah.
What
I'm sorry.
to D?
Where's 74? Okay. Is that the same place?
Yeah, it's 95.
Oh, wait. You're right. 95 for here. But don't forget this tail. What was this tail?
2.5. Wait, no.
Yeah. This tail was 2.5.
Wait, sir, but is that the third standard deviation? 99.7?
Yeah, but we're not going there.
Oh, yeah, okay. Yeah.
No, see, we're only going the area to the left all the way, including the tail. So you're right, 95 plus 2.5 says the height must be greater than or equal to, say it again? If you want to be in the 95, no, that's it. No, it's okay. 74. Just
Equal to
if you're greater than 74, then you are in that top percentile. He wants to know what percentile was exactly the 74. And that was the 9, did you add it up? 97.5%.
Wait, Mr. Carter, what was after the D again?
B, I erased it.
D.
D.
67 to 74.
Okay, so yeah.
Yeah, didn't you answer that?
Yeah.
Yeah. All right, good, there's still 5 minutes. Let's at least see if we can set another problem up here.
I don't know, sir. I don't know.
The length of human pregnancy. I like how she says that. I'm not really sure, sir. We'll see. The length of human pregnancies from conception to birth varies with an approximate normal distribution with a mean of 266 days. So allow me to put 266 right here. And what was the standard deviation? So if I add 6, what's this number?
272,
If I add 6, what's this number?
78,
Oh, 278. If I add 6 more,
284,
284. Why am I doing that way? Take away 6.
260,
Take away 6.
254,
Take away 6.
48.
There you go, babe.
All right. So that's the most important step. Draw your numbers on the number line. I need 7 numbers. The mean or the median, and 3 to the right, 3 to the left. What does A say?
How long are the longest 16% of pregnancies?
60?
16.
Longest 16. Where would that be?
The first, standard deviation, like to the right of it.
No, that'll be 34.
Well, 34. Well, but one tail is 16. Think about it. From here to here was 68.
Yeah.
The tail must be added up to 32. This tail must be 16. This tail is 16. Would that not be the top 16%?
Yes.
So what's the days?
284. Wait, sir, but doesn't it keep on going?
What, here you mean?
Yeah, cause.
Yeah, but it all adds up to 16%.
No, but like, cause it says how long are the longest 16% of pregnancies? So like.
They're any day longer than 272. They're in there. They're in here.
Greater, cause it's asking for.
Yeah, any of those days are in the highest 16%. Any of those days, so I'm going to say greater than or equal to 200 and what? 78? 2 days. So I'm going to say the pregnancy length, the length is greater than or equal to 272 days. How about the shortest 16%? Well, that's already done. Less than what? Right here.
Yeah.
Length is less than
260.
260 days.
No way.
Yeah, you're right. Middle 95. That's not going to use these numbers.
260, no, never mind. 254 to 278.
Oh, say it again.
254,
You want me to go down to here and up to?
278.
Because it's between 2 standard deviations, you get 95. That's right. Is this clear as mud?
Yep.
Okay, good. Clear as mud?
Oxymoron.
Yeah, that's more like it. Hey, he called me a moron. Hey, you hurt my feelings. Now, watch the YouTube video on inverse norm. Finish up that worksheet if you haven't done it. Now you owe me 2 pages of the exercises.
Wait, which one's that?
You now owe me 2 pages of the exercises.
Mr. Carter, I can't exercise that one.
The one from
The-
standard deviation?
And
The one from density curves?
the what? Well, that's 1 page. That's the worksheet. But in the packet of exercises, where's your exercises?
Sir, that's the same question I have.
Okay, I'm going to say goodbye to the class. Bye, class. And you said, can we do it? And I said, no.